Need me drawing for you to set up what a rectangle garden looks like. What would it look like? Please, somebody say rectangle. Thank you. Excellent. Nice job. The garden is X meters wide. Where is the width on this? The way I've drawn it, the way you've always been taught. What do we consider to be the width? The left and right side, the shorter sides, right? So that is X. What does that automatically make this? Y, because it's a different number, right? Because it's a rectangle. Agreed? All right. So I wish, question 1, to find the length and the area in terms of X. What does that mean in math class? If I want something in terms of X, what does that mean? Pardon me, George? You're on the right track. I think you may be right. I'm just not sure if you're saying what I think you're saying. Anybody else? How many terms do I have in this rectangle right now? 2. What are they? X and Y. I want it in terms of X. So what does that mean? Pardon me?
The answer for X.
I don't want an answer yet. Right now I have X and Y. I want terms of X. So what do I have to get rid of? The Y. Okay? That's what we mean. So we know some stuff about this rectangle, don't we? What do we know? Pardon me? Right. There's 2 X's and there's 2 Y's. What else do we know? Rhea. Not yet. We're still working on A. The perimeter is 100, so we know this has to equal 100, yes? Now, would we write it that way? What should we do to that to make it easier to work with? Jack's going to finish his mouthful.
2 and then inside brackets X plus Y.
Yeah, you could do this. X plus Y equals 100. And then what? What would make it even easier? Well, we'll get to that in a second. Rhea. Divide both sides by 2. So X plus Y equals 50. Are we agreed? Okay. Excellent. So there is something we know. Now I want to find the length, this Y, in terms of X. Well, if X plus Y is 50, right? Then what must Y equal? 50 minus X. So the length must equal 50 minus X. Are we happy? Do I know the length using just the term X? I do, right? Okay. Now I want the area in terms of X. Well, what is area if we were in grade 3? LW. What is area with this question? XY. But Y is what? 50 minus X. So the area is is X times 50 minus X. Is everybody cool to there? So that's A, done. Now let's work on B. B says find the width of the garden with an area of 525. Right? So we know that area equals X 50 minus X, right? What else do we know? working on B now. What else do we know? The area is 525. This is what Rhea was talking about. Now, I want the width. The width is x, yes? So how can you tell me what x actually equals? What are you going to do right now? There's a lot of things you could do right now. Somebody give me something that they would do. I will take any suggestions. We need to know what x is, which means x must be what? Isolated. How will we isolate x? I know it's Friday afternoon. I know it's gotten sunny. But you all have brains in your head. What would you do, Harkirat? You could distribute the x. Now, can we do something with that? That's starting to look pretty familiar, isn't it? What could we do with that? You could put it in standard form, which would be what? X squared minus 50x plus 525 would equal what? 0. Because we don't have a y anymore, do we? Everybody happy with that? Does that look like something with which we can work? What is something we could do with that? Pardon me? You could maybe factor it, right? So I'd need numbers that multiply to 525 and add to 50. One positive, one, and both have to be negative, don't they? Okay? So if we were going to factor it, I'm going to slide over here because we'll need some space. What would you divide it by? You'd go 25? Perfect. 25 goes into 500 how many times? Yeah. How many quarters are in a $5 bill? 20. And then there'd be 21, right? So 21 times 25. Yeah? Is that 50? No, 25 squared is 625. So 25 and 21 won't work. But it gets close, doesn't it? That's 46. Okay? It ends in 5, so we should work with 5s, yeah? Let's try another one. Will 20 go into that? No, because it ends in 5. Will 15? What is it, David? 15 and 35, right? X minus 15, x minus 35 equals 0. Do I know my two roots now? What are they? X could be 15, x could be 35, right? Everybody cool? Okay, does that tell me what I need to know? Sure it does. Because I'm looking for the width, right? Right now, x could be 15 or 35, right? Which is it? If that's 15, that's 35. Are we cool? If I call this 35 and that 15, are we cool? So if the width is 15, obviously the length is going to be what? 35. So do we know our width? So x has to be what? Either 15 or 35. Everybody good? Okay. What are we going to do for C? What does C say? Find the maximum area, yes? So if it's a maximum area, what kind of parabola do we have? Is it happy or sad? It's sad, right? Where does the maximum live? At the vertex. So that vertex is going to have an x value, isn't it? And that x value is going to be the width that will give us the maximum length, or maximum area, isn't it? So, how will we find the vertex when we have x squared minus 50x? Sorry. Let's go back to the very beginning. This is where we were. 525 equals 50x minus x squared. How will we use that to find the vertex? Pardon? I could complete the square. That's one option. What else could I do? I only need the x value of the vertex, don't I? Isn't there a way to find the x value of the vertex when I'm in standard form? What is it? From this form, how can I find the vertex x? Complete the square will do it. It'll put it in vertex form. We could complete the square, but all of you hate completing the square. So I'm trying to get you to remember the other easy way. What? Yes, it's a bit of the formula. Which bit? Is it? It's the front bit, which is negative b over 2a. What's negative b? Here. This is weird, right? Is this in the right form? Okay. Positive 50? Okay, so that means you've done this, right? You've gone negative x squared plus 50x minus 525, right? Because you've brought that over to put it in standard form. That's what everyone agrees with? Well, let's... When I asked what b was, a bunch of you said negative 50, which means this is what you had to do. Let's just see if it works. Everybody cool? So it's going to be negative 50 over what? 2 times negative 1, right? What's negative 50 over, what's 2 times negative 1? Negative 2. So what will x equal? Positive 25. Now, do we know if we're right? Can anybody think of a way, with the work we have on this page, to let us know if that is right? This parabola would graph like that, right? Okay. Do we know the roots of the parabola? What are they? 15, right there. And 35, right there, right? Where must the vertex be? Exactly in between them. Is 25 right in between? What's 15 plus 35? 50 divided by 2. So is our vertex correct? So if our x value is 25, and the area equals x times what? 50 minus x, right? What's x? 25. What's 50 minus x? 25. So 625 is our maximum area. Everybody understand? Even if you don't understand, the math got us there, right? Now, are there other ways to do it? Could we have completed the square here? Sure we could have and gotten vertex form. No problem. Would have worked fine. Right? Because once we know the x value, we can plug it back into the equation. That is the key to this entire unit. What if I'm using time and speed? Do I still have an x and a y? The x is the time. Find the x, plug it back into time. Everybody cool? Everybody's okay, right? No graphing calculator. We're able to do this in our sleep, right? Maybe not in our sleep, but we're able to do it. Let's try the next one. Turn the page over. What's weird about 115? It's physics. What's weird about 115? Do I have an equation? It's right there, right? What's weird about it? It's different variables. That's one difference. What else? Pardon me? There's a decimal. What else? It's not in standard form. Can we fix all of that? Sure we can. H on our graph or on our calculators is what variable? Why? Because it's the output. T is x because it's the input. Because t is the independent variable, right? Am I throwing a ball off a cliff right now? Yeah. Am I throwing a ball off a cliff right now? Is time passing for me? Are you throwing a ball off a cliff right now? Is time passing for you? Somebody somewhere in the world is throwing a ball off a cliff right now, aren't they? Not maybe. There's a kid on a cliff right now throwing something off the cliff. Every time you get near a cliff, you throw something off it. Don't tell me you don't. You've never been near a cliff. At least you throw yourself off a cliff into the water. You have thrown something off a cliff, every single one of you, right? Is there anybody other than Jack who really hasn't thrown anything off of a cliff? I am appalled. Anyways, fine. How can I rewrite this to a form we're comfortable with? What would I do? I just change it around. What does H become? Y equals. Now what should I do with this part? Switch it around so it looks like standard form, right? Negative 4.9t squared plus 24t plus 1, right? Now, if you didn't have a graphing calculator, could we work with this? Sure we could. What is that? What's that? A. What's that? B. What's that? Can we do completing the squares, factorings, anything we want? Can we use Vx equals negative 2 or negative b over 2a? Could we complete the square? All that is doable, isn't it? But we're going to need our calculator, aren't we? Right? Because if we're going to be using 4.9, we're going to need a calculator anyway. Do we have access to a graphing calculator? Let's use our graphing calculators. I have a box right here. But not until you tell me what you would do regular style. So, I want the maximum height of the ball. A. Do I want a y value or do I want an x value? I want a y value because it's an output, right? Where does the maximum height live? The max height is the vertex, correct? And the vertex has coordinates of x and y. Agreed? Which of those can I find right now? Can I find the x or the y of the vertex from the standard form? Which can I find? The x. How would I do that? Vertex x equals what? Negative b over 2a. What is negative b? Negative 24. Over what? 2 times what? Negative 4.9, yes? Which would be negative 24 over negative 9.8, which would give me what? Yeah, 9.8. Oh, gravity! I'm throwing something off a cliff. Imagine gravity's helping it. How are you going to get that? You can't get that in your head, can you? I mean, you can, but can you? So we're going to go to a calculator for that anyway. What is it? It's going to be around 2.4, right?
2.32.
What is it? Somebody with a calculator do 24 divided by 9.8. Pardon me? 2.44. So that means the maximum occurs at 2.44 seconds, right? How do I find the height if I know the maximum time? Where does that go? Plug in for t. Once I plug in for t, I would get the height equals negative 4.9 times 2.44 squared plus 24 times 2.44 plus 1. Agreed? Easy to do with a regular calculator. Right? Right? Okay. How would I do B? Okay. That gives me a height, right? So I know that it has to be 20, right? I want higher than 20 meters, yes? So how would I write that in math class? 20 is greater than or less than? I want to know when the ball is higher than 20 meters. So is 20 the lowest one I want to count or the highest one I want to count? Lowest. So 20 must be less than the whole parabola, right? With an old-fashioned calculator. Is everybody cool? Okay, come and get a new one. Let's work through this with the graphing calculators because it's a tool I want you to know how to use. Everybody come and get one. Bring something. Trade it in. I only have like 18 or 20 of them. I just have paper towel. They're the same. They're just different colors because these are the older models. If you have your own or if you've gotten it on your phone, use your phone. All right. First of all, let's do a couple of things. Everybody get to our Y. Everybody get to our graphing spot. What do I punch in there? Negative 4.9 what? What button do I hit now? xt theta n squared plus 24 xt theta. They're all the buttons are in the same place as mine. You just have different colors. Then plus 1, right? Now what's going to happen when we push graph? Because everybody's got different windows, don't they? What's going to happen? Are we all going to see the same thing? No. That's kind of yucky, right? Do you guys see that? Okay, so what do we need to do? Right now, I know what my window is. You know what your window is. We need to fix our windows, yes? to do a good job with the parabola, what 3 parts of the parabola should we see if we're going to work with it? There's 3 things we want to see. What are they? The 2 roots and vertex. So for me, I can see the 2 roots, right? Do I need any of these negatives? No. So I'm going to change my window to -2, right? Because I don't need any of the negatives, but I don't want to be right on the edge of the screen. I want to be able to see what's happening. Do I need any of these positives? No. So 1, 2, 3, 4, 5. I don't need anything past 5, do I? So I'm going to change my window for the x's. So I'm going to go into window. My x minimum, I'm going to make it -2. And what did I say? I said my x maximum was 5. I'm going to make it 7, just so I got some room around it to work. Everybody cool? So all of you can do that. Let's check our graph. Oh, now we're in better shape. What don't we see? The vertex. So what do I got to change? I got to change y. Do I need any negatives, really? Can the ball go lower than the ground? No. But I'm going to put a couple of negatives so I can see the y-axis and the x-axis. So I'm going to go in here. My y minimum, I'm going to make -2. What should my y maximum be? We know we have to go over 20, right? Does it really matter what we make our y maximum? We just want to see it. What do you want to make it? 300? You can throw a ball 300 meters in the air? Damn, son. I'm going to go 50. And should I change the scale? Doesn't really matter. But if I change the scale, then I don't get a million little dots, right? So I'm going to change scale to 5. What does that mean each dot on my graph is now worth? 5? I'm going up to 50. So each dot is worth 10. Graph. Sweet. Everybody cool? Now, we wanted to know the length of time the ball will be higher than 20 meters, correct? So this path is really a drawing of the path of the ball, isn't it? It's not always. Hey, Mr. Whitman.
Man, real estate sure cheap down south in Central America.
Yep. We're in the wrong line of work up here, buddy.
What are we doing?
I know. We'd be millionaires down there.
I know we'd be.
We'd have 4 or 5 servants. I know, man.
I treat them well, though.
Oh, of course you treat them well.
With respect.
You have to.
Total
They're cooking your food.
Well, I get a taster, a food taster.
Oh, damn right you'd have a food taster. We're rich.
Yeah, so we got that. So we're really screwing up here.
Mm-hmm.
We're dumb. Okay.
Yep.
I'm looking at the where's the place that Andy Dufresne ended up in the.
That's Zihuatanejo.
Z1.
Zihuatanejo. West coast of Mexico. Deep south.
What just happened?
Huh?
What just happened?
Mr. Whitman probably has a spare right now. Mr. Whitman is closer to retirement than me. Oh, so he's got a spare. All right. So, right. We're trying to find how long the ball was above 20 meters, yeah? 20 meters is on the y-axis, right? Everyone agree? Okay. Everybody got to go back to your y value here. Go down to the second line and put y equals 20. What will that do? It will put a line across the graph. At what level of meters, Jazz? 20. Some B. Now, what happens right there to the ball? It is 20 meters high, right? And doesn't that have a time? Does, doesn't it? What happens right there? It crosses below 20 minutes. Does that have 20 meters? Does that have a time? So if I can find those two x values, Do I know how long it was over 20 meters? How will I find that x value, do you think? What do we push on the calculator to do work with the graph? Second, calc. Now, which of those things are we seeking right now? Am I seeking a value, a 0, a max, a min, or an intersect? I'm seeking an intersect of two lines, aren't I? So, intersect. First curve. Am I on the first one right now? Is my cursor on one of the lines? Okay, let's move it down. Close to my other curve. Am I close? Enter. Now I'm on the second curve. y2 equals 20. See, my calculator tells me which one I'm on. Am I happy? Okay, let's check the intersection. Do we want to guess?
Yes.
Of course we do. That's what we're asking you, calculator. What is our x value? 0.9929748, and that's exactly 20. I want to be over 20, right? So is it cool to say 1 whole second? Excellent. You guys find where the second intersection is. So we know for B, it starts. There they are. It starts at 1 second. When does it go back below 20? Use your calculator to sort it out. Sure. What's that one? 3.9. How do I find out how long the ball was above 20? Add them? Add them? The ball went over 20 at 1 second. What is happening to the ball right now? Still over. What happens right there? It stops being over. How do I find out how long that was? The difference, which is what? 3.9 minus 1, Jashin. 2.9 seconds.
Would it be negative? Actually, no.
Oh, it wouldn't be negative. Can time ever be negative?
No.
There you go.
I learned that from physics.
You learned that from me last year in grade 10. Because you can't pedal a bike back through time. Remember that graph?
No.
Hurtful. Okay. Now, we've done one without a calculator. We've done one with the calculator. We've done one with a graphing calculator. Everyone's cool, yes? Now, let's put it all together and decide which one we're going to use here. Read the question. Now, there's a bit of a typo there. That's supposed to say kilometers per hour, and there's not supposed to be a little -1 there. I don't even know where that came from. And this, ladies and gentlemen, please notice, is the very last question of this unit, yes? Which means it's a lead-in to what? The next unit. So this is going to take the skills we have from the previous unit, and we're going to apply it forward. What do I know about this situation? Read the question, tell me some stuff I know. Exactly. Louisa will take 3 hours to ride the bike. You should not go to Mexico and say that's a funny name. That's a pretty common name. Yes. What else do we know? We know her downhill speed and her uphill speed, don't we? How do we know that? Okay. Do those speeds change? Those speeds change, right? They're not the same number. Okay. So I have 2 different speeds, don't I? I have downhill speed and I have uphill speed, yes? Everyone agree? Okay. What are the 2 things that are being counted here? It's a bit of a physics question. There's 2 things being counted here. Pardon me? I am counting distance. And what's the other thing I am counting? What's the other thing I am counting? Time. Hey, our carrot's just given me away. Is there a relationship between distance and time? What is it? Yes, speed or velocity equals what? Speed equals distance over time, correct? If I am counting 2 variables, can I make one of them x and one of them y? Which one of those would be x? If we were using our graphing calculator. Time. If we're not using our graphing calculator, can we leave it as t and d? Doesn't really matter, does it? Okay. So, we know it's going to take 3 hours to ride the bike, right? Everyone agrees? She's riding uphill and downhill. So, how many different times do I need? How will I put this into math? What do I know about the time she rides downhill, the time she rides uphill, and her total? Okay, time 1 plus time 2 equals her time total. What's her total time? 3 hours. Her time downhill plus her time uphill, yes? Well, speed equals d over t, right? What else do I know? If speed equals d over t, what else do I know? I know her speed is 35. Do I know a distance? Distance from the bottom to the top of the hill is 40. So her distance is uphill is what? 40. Over what do we know here? Do we know the time uphill? No. But we also know what's her downhill time. Read the question though. Her average speed is 35 kilometers faster than her uphill speed. So is 35 the right thing there? Okay. So we're in trouble. Go back to your math. What do I know there? I know I need times. What should I do to that to find a time? He waited patiently. Pardon me, Avneet? Speed times distance to get time isolated? How do I isolate time? Multiply both sides by t. Cancel. Distance equals time times speed, right? I don't want that. I want my time. What do I do now? because I need time 1 and time 2. What do I do now? Move the t. How? By dividing by s. Time equals distance over speed. Thank goodness. That didn't take very long. So I need my first time. Distance over speed. Are we going to call that the uphill? Or the downhill? Does it matter? What do we know about her speeds? Do we know any of the speeds she is traveling? Do I know any of the speeds? No, what do I know? I know the distance is 40 divided by her speed. What was her speed? Do we know? So what should I put there? X? Okay, make it X, all right. We know the downhill speed is 40. What's her speed downhill? Read the question. What's her speed downhill? X plus 35. Everyone agree? Now, do I have an equation there? And remember, this is leading into our next thing. Do I have an equation here? Okay, could I solve that? What would you do to make this look prettier? What about that makes you pee your pants a little? Because stuff on there makes you pee your pants a little. I've taught math long enough. What bothers you there? Fractions. Thank you, Jack. How would I get rid of that x? Multiply what? Everything by what? X. What's going to happen to that x? It's going to what? X over x. What's going to happen? Cancel. 40. Oh, I see what you're saying. All right. Plus 40x over what? Still x plus 35. I can't cancel that x because this is x plus 35. Equals what? 3x. Now what makes you pee your pants a little? X plus 35. Is it on the bottom of a fraction? So what should I do to get rid of it? Multiply by what? X plus 35. X plus 35. What's going to happen to these x plus 35s? Cancel, cancel. So I've got 40x plus, what's 40 times 35? $1,400 plus, these have canceled, so 40x equals, what's this? 3x squared plus 105x. Now, what do you see there? You see like terms. What are you going to do? I would tidy it up right now, yeah? 3x squared. Bring over how much? How many x's? Once they come over, what do they become? Negative. What's 105 minus 80? Plus 25x. And what's going to happen to that 1,400? It's going to come over and become negative. And what does that equal? Zero? It could equal 0. What will it always equal? Isn't that standard form? So what does it equal, Noah? Y. Can I work with that now? Once I have an x value, can I then find my speeds? And that's what I would do. That took a long time. I don't want to go too much further with that. How would we find an x value there? What would we do? What gets us an x value there? How do we find x values? Now we do what you said. We make it equal what? We make it equal 0, and we get two x values, right? What are those two x values? They're roots, aren't they? Once we have roots, we can go back in and find the speeds because we have x's right here. Now, do I expect you to be able to do this yet? I expect you to be able to do this now, right? All of this is the new stuff. That's what we're leading into. But please notice where we are going next unit is what we already know how to do. Okay? Everybody's cool? All right. Now, the next thing in here is your review. If you wish, you can tell me what this answer is. That's cool. Your review is the next thing. Don't look. The answers are there. The review starts on the next page. It goes until page 121. 119. When's that review due? Monday. We mark it Monday. You will notice on page 120, there's a big old page that says test reminders. Yeah, 2 blank pages. What am I going to do for the rest of Monday? Give you some test reminders so everything is in one place to study from. When will you write your test? Now, here's the problem. Wednesday and Thursday are shorter days. They're hour-long days because of early dismissal. Then you've got 4 days off. I have 2 assessments I like to give you for quadratics because so much is going on, right? Right? So here is my personal suggestion. I would like to give you your, on Tuesday, I would like to give you an open book assessment. Okay? You can use your graphing calculators for it. There's parts that I don't want you to use them, but we can sort that out when the time comes. Tuesday, I would like to give you an open book one with the whole 80 minutes because you people tend to look stuff up that you already know if I say open book. All right? You don't trust yourselves. So I want to give you 80 minutes for that one. Everybody cool? Wednesday, I want to go over that. Then Thursday, I want to give you your closed book one. And then we're completely done with quadratics. We have a 4-day weekend. We start something new. You don't have to go away for your 4-day weekend and be worried about a test when you get back. That is my suggestion. Acceptable? Okay. Regular review. Due Monday. We go over it. Open book. Practice. When I say open book, does that mean you can work together? No. Tuesday. Wednesday, tie it all together. Thursday, show me what you know. Deal? Okay. Thursday's test, I will tell you right now, has some graphing calculator, some not graphing calculator, and some that I don't care. If you want to use the graphing calculator, you can come and get one. Deal? Everybody cool? Go. Now, you guys are going somewhere, I assume.